Welcome. We're working on section 5.1. That's finding the area between curves. I'm on page 507, and I'm going to work problem 22 here. So the instructions are sketch the region bounded by the graphs of the given equations and find the area of that region. And we're looking at the equations y equals 2 square root x minus x and y equals negative square root x. So I wrote down those two problems. Let's see, I know that the domain of both of these is x greater than or equal to 0, simply because I can't put in a negative number for x and get out a real output. So let's start there. At 0, I guess this thing is 0. At 1, I guess I get, when x equals 1, I get 2 minus 1, so that's 1. Let's say that's 0, 1, 2, 1, 2. Let's see, when x equals 2, that's some sort of other number. Let's see, when x gets out to 4, when the input is 4, this is going to be 4. This is going to be 4, so 4 minus 4 is 0. So I have something like that. I guess this will go up, and then eventually this will go faster. So got something like that, just roughly at least. This right here is 0 at 0. At 1, when x is 1, it's negative 1. I guess we ought to have this come down. Negative 1. At 4, this is going to be negative 2. So this is just that classic sideways parabola, the bottom half of it. Let's see, so I guess we're hoping that these things actually collide somewhere over here, so I get a region between the curves. How do I figure out where they collide? Well, I know that they collide at 0, but how do I figure out this point? I'll set the two equations equal to each other. So where is 2 root x minus x equal to negative root x? I suppose I could add root x to both sides. Or perhaps I'll just subtract this over to the other side. I'll subtract 2 root x from both sides. So negative x equals negative 3 root x. Why don't I multiply both sides by negative 1? Now, really what I have here is I have something where I suppose I should square both sides. So I get x squared equals 9x. And then if I pull this back over to the other side, I could factor this thing out. So I get x times x minus 9. So this intersection actually happens at 9. And I could sort of double check that if I was skeptical of my math. Let's see. So if I plug in 9 here, I get 2 times the root of 9, 3, so that's going to be 6 minus 9 is negative 3, and here I get minus the square root of 9 minus 3. So, okay, so these collide, and they collide at negative 3. So if this dot was out here at wherever that is, 9, negative 3, this is what my shape looks like. Now I'm supposed to calculate the area of that shape. Not amazingly beautiful, but hey, how do I calculate the area of that shape? Well, that's going to be an integral. I'm going to slice from left to right, taking boxes like that, and my box is going to have area. Height, well, what's the height? The height is the top function minus the bottom function, so it's going to be 2 root x minus negative root x. Notice because this is below the x-axis, it'll actually add to the height. There's the height, times the width of the boxes. Well, that'll be dx in the integral, and I'm integrating from 0 to 9. You can see those two things come out of solving that equation. Okay, so let's go ahead and try to integrate this. What do I have? The integral from 0 to 9 of, this is actually 3x to the 1/2 minus x dx. So that comes out to, let's see, x adding 1, I get x to the 3/2 times, there's the 3, and then the reciprocal of this is 2/3, so really that's 2x to the 3/2 minus 1/2 x squared, evaluated from 0 to 9. Okay, so let's see, I suppose that is 2 times 3/2 9. Well, the 9 to the 1/2 power is 3, so I get 9 to the 1/2 is 3, 3 to the 3rd is 27, okay, minus 1/2 9 squared, which is 81. That seems profoundly problematic to me, because that is going to be negative. That's not so problematic, I suppose. This is 54. This piece is half of 81. Half of 81 is, let's see, what is that, 40.5. So I suppose when all the dust settles, we have 13.5 as the area. Notice I really am implicitly plugging in 0 here as well, but 0 gives me 0. Okay, so that's the area.